Hi there. My name is Wemp, and I'm a candidate for the EdTech Master's Degree program from Boise State University. I started the EdTech Master's program in 2009. Had a small hiatus, or actually took 1 or 2 years off, and then came back in 2013 and continued my studies from there. Um, One of the draws that I had for the EdTech program is that it was online. It would be able to offer me the ability to learn how to teach classes online, and it would give me a lot of skills that would help with creating online curriculum and digital curriculum that can be used all over. Once I started the program, I quickly found that some of my experience as a teacher was very helpful. The pedagogy with teaching doesn't change from online learning, virtual learning, digital learning to traditional learning. Learning is learning, and solid skills that come with learning are the same in an online environment. The difference is the tools. The tools to be used in an online environment or in a digital world are very different from a standard classroom. And many of the courses that I took throughout the time in this master's program, many of those courses actually helped me to create lessons and curriculum that I could use in my classroom right after I took the class. Some good examples I'm going to show you in this video of some artifacts that I created in different courses that I was then actually able to implement into classes, or think about my students as I was creating these lessons. Some of the things I wasn't able to implement right away, but I was able to share with colleagues, or when colleagues wanted to create something digitally and have students be able to work outside the classroom. Some of the pieces that I had learned from these courses, I was able to share with them and actually help them with instruction. So one of the pieces that I'm planning on doing is getting a certificate in online teaching K-12, and one of the big draws that really pushed me towards taking these courses and actually getting this master's degree is the fact that there's a big push for online education in my state of Idaho. I teach pre-engineering, and that's one of those courses that is not typically offered in an online environment. And I wanted to be able to give myself the skills to be able to help create an online environment where students could get pre-engineering classes at the high school level. And typically that would not be something that an average teacher would know how to do. So a lot of these courses were very helpful with that. My hope is that at some point I would be able to implement some of my skills in creating some of these lessons for an online environment. That being said, I can see great value in online learning in outside of the classroom, in an organization that has satellite employees. There's a lot of training that has to be done, and that training can be done in a virtual world rather than bringing people in from across the country for training. I'll give you a perfect example of that. My current position is with a curriculum developer. That's a national organization, and that national organization is based in Indianapolis. I'm based in Nampa, Idaho. So I will be flying out to do some training with my team, who's also from the Western United States. I'll be flying out to Indianapolis so that we can all get together and do some training. Now, it's my belief that it's a good idea for us to all get together, but generally speaking, we've done a lot of our smaller trainings in a virtual environment using tools like Skype, GoToMeeting, different online tools that will allow us to be virtually in the same work area. So anyway, that's a little bit of my background. Some of my program had started quite a while ago, and so one of the things that I found interesting in developing my rationale paper is that some of the courses, specifically EdTech 501, 502, and 503, I took those quite a while ago, and the courses changed fairly significantly between now and then. So as I'm reviewing other students' work, what's really neat for me and a little bit disappointing is the fact that I can see how that class has progressed and really picked up with the new technologies and run with it. So some of the stuff that I did and that I have as for my reflection isn't necessarily as up to date as some of my classmates. So it's really been interesting to see all the work that they've been working on. So one of the cool projects that I got to do in the EdTech program was actually in EdTech 541. In EdTech 541, we actually had to create an interactive presentation. So the basis behind this interactive presentation is that as you work through the presentation, it has you work in different pieces and parts. And so what I chose to do is an introduction to circuit theory. So I used some outside resources in the presentation in order to allow the user to go through some of the learning material and then actually work with the material while they were learning about it. So this created sort of an asynchronous environment, and it was kind of the introductory environment where the learner could be getting some new information, and they can actually take that information and view it at their own pace and then determine if they had done it correctly or not, and then kind of move through. So the foundation of an online learning environment and a virtual learning environment, I felt, was kind of started in this particular project. And so the students would go through, and as they clicked on pieces, they would start to learn about electronic circuits, and they would see a series circuit and a parallel circuit. And these are screen grabs from a simulation software that they would use. So as a student progressed through, they would get some key terms, and then they would see an example of a series circuit. And then down here towards the bottom, you would see some arrows popping in. So these arrows would show up as the learner continued through. So by clicking to advance the slides, they actually were interacting with the slideshow as opposed to just getting the information, writing it down, and moving on. They actually could see a visual. Now again, this is sort of a basic level, and some of the other artifacts I'm going to show you kind of build off of this, ultimately culminating in an evaluation of a program. But you can see that the presentation is not static. So in this slide, they're going to go ahead and try building a series circuit, and then by clicking on the picture, it actually takes you out and throws you into the PhET simulation environment. And so in this environment, you can actually go ahead and start running. So here you can see the Java applet that opens up, and then you can go ahead and create your circuit. And you can wire these from here to here and just kind of make it go around. Put a light bulb in, bring that up there, and this is a pretty sloppy wiring, but you can see it's interactive. So the students would do this, they'd play it, and they'd be good to go. So at this point, they will have tried it. We'll minimize that, go back to our interactive presentation, take it back up to full screen, and then from here it said try building a series circuit, and then they can go ahead and run it now. So then it starts to get into a parallel circuit, which is another type of circuit, and you can see the demonstration's a little bit different, and the arrows start to look different. The arrows represent the travel of the electrons. So you can see the arrows have popped in. So now in a parallel circuit, you have different levels that the electrons can flow through. And again, it would take you back out to the PhET site by clicking there, and it pops you out to there, and you can start up again. I'm not going to go through that though. More key terms. So the learner is learning a few more key terms, and then they pop into some integrated video. So again, we're still in the Google Slides, and now you can go ahead and watch video, and it plops you into a Khan Academy video on Ohm's Law. So I'm going to go ahead and pause that, and you can see that if you click on here, so now you just got some interactive lesson. You exited, or you didn't exit the presentation, but you got some outside sources, and then you can continue on. And so as we go through, we're doing some calculations. Calculating for current, it gives you the formulas, and it's got some nice little pieces on there that the students would then work through. So in this situation, it's asking me, okay, let's try it out, and it wants to know, it's like a little quiz, what is the current in this circuit? And the way that I've got this set up is that you can click on one of these, and it will tell you if, oh, I'm sorry, but that's the wrong answer. So click here, try again, it brings you back. So the student would have to go through and calculate this and then choose the correct answer, and eventually keep calm because you're correct. So there you go. So that was the right answer. Moving on, and then it goes to some cool little tools that the students can then use to do some of these calculations. So like quick calculator for Ohm's law takes you out, brings you into another website where you can actually do Ohm's law calculations. So after the student actually learns how to do these calculations, they can go in and plug them in. So then, and the presentation continues on, but this is a presentation that I've actually been able to use with students after we have gone through some of the basics of series and parallel circuits and Ohm's laws and just basic circuit theory. I've been able to use this presentation and just embed it into my classroom website where students could then go on here and work through some of this stuff some more. Obviously, they can search through and get videos from the Khan Academy or something like that, but what they're actually able to do here is to pull some extra information that's from me, and it's kind of in a learning environment as opposed to just them being responsible for figuring out what they know and what they don't know. So it's sort of a review, and it's also interactive for students. So they're not just going through a slideshow on how to do it, they're actually getting some interactive components where they have to solve some problems and put their work into action. So here we are in EdTech 521, and this is an asynchronous lesson that I'll be showing you as another one of my artifacts. So in the last artifact I showed you, we actually had an interactive presentation. The student can learn about some information on their own. In this particular project, this is an asynchronous lesson that a student would actually work through. And so what they had to do is they would actually be working on this. This particular one is about thermal energy. It starts out with the equation on thermal energy, and then the students would work through some of the learning targets on their own, or not necessarily on their own. They would have my help, but they wouldn't be synchronous. They wouldn't be at the same time. And so this would be something that a distance learner could do on their own without having to actually be in the room. So the way I've got it built is that I have some interactive learning tools going on. You can see I've got some video that students can go ahead and watch, and it actually comes through, and it's some notes on what we would be doing in class. So this is a video that I created, and I will let's see, I think I'll be able to play that for you in the video on its own. But anyway, I created this video and then I uploaded it to SchoolTube, which is a version of YouTube, and it's a good introduction. Then the student would have the objectives and any concepts that were being addressed and what is it that they're actually doing. So then again, we'd come in and we have some thermal energy notes. Again, this is an embedded video, so it's actually part of the lesson itself. This is another video I created, and if I bump ahead a little bit, you can see it's got some notes that I'll be taking and using, and then from there the students would actually go into something else. So I've also got a link here for hyperphysics. This has some other video demonstrations that students can use. It takes them out, and then they actually do a conduction practice problem. So again, another video that I've worked through to give them some practice on a conduction problem, and another conduction problem here. Both embedded videos that I've been able to use. One of the cool things that I was able to do with this particular project is then not only do I have a lesson that a student could use if they aren't there on the day that we're talking about thermodynamics, but it's also open to the public. So you have students coming in that aren't all necessarily my students, and they're pulling these up and able to work through these problems. I'll discuss that a little bit more in the next lesson, which is a full online lesson, because I did have a number of students come in and work on that particular project that weren't necessarily even in my own class. So one of the neat things about the online environment is that if it's an open environment, like this one is, where it's easily searched and people can have access to it, students can actually run through it and work through it without being part of your class. So then practicing your skills, again, I have another PhET simulation from the website that students can work on, and then they're going to use a worksheet that's provided on the website in order to kind of work through a simulated lab, if you will, lab environment of this problem that they're working on. Then I've included a virtual experiment so that students can actually go through and create an experiment that they could do in home without necessarily having to be in the lab or in the classroom. And they're to go out and find materials and see how well that material insulates against the loss of heat. So how good of a heat conductor is it? Then there's a quiz. Now that you've played the thermal energy transfer, it's time to see what you know. So click here to complete the quiz on thermal energy. So if I click on that link, it takes me to an online quiz that I've provided. This is in Google Docs. And then there's a rubric for answers to see how you did. And then just a general performance rubric. And then I would fill that out. And then still need help, you can email me to set up a time. Click here to join the meeting when it is time. So basically this is a asynchronous lesson that I was able to do, and students can actually use this outside of the classroom time. So for instance, if you're not in office hours, you wouldn't necessarily have to be there to help the student individually with the particular project. So in EdTech 523, I created a online lesson. So this is a little bit different than an asynchronous lesson that went through. The asynchronous lesson was one quick little thing. This online lesson is actually more of an online unit. And what it deals with is 3D modeling on a computer. So if you wanted to create an object in 3D, you could go through this lesson. Interesting backstory to this lesson. I've had a number of students outside of my classroom using it. I've had a number of my actual students using it. And I got an email about 3 months after I created this unit from what I thought was a student in Louisiana. Turns out it was an intern at a design firm that was working and trying to learn how to use the 3D modeling software, and she had actually just found this kind of walkthrough and was working through it. And so she was asking me for some more details on the drawing so that she could do some more work on it. So it was kind of interesting that from this lesson that I created in the EdTech program, I was actually able to not only implement it in my own classroom, but it became a learning tool for people outside of my own classroom. People I didn't even know, and I didn't even know were using it. So that kind of demonstrates the power of the online tools. So if we go through this, I'm not going to go through the whole entire thing, but there's some key points. One of them I wanted to point out was a conference room. I called it a conference room. It's really just like a forum area where students can go in and they could actually create help questions, and they could work through stuff together. So the idea being very similar to how we have it in our EdTech program, where students can actually go in and work through pieces. As the instructor, I can post things. It's basically just a little forum. I like the term conference room a little bit better. I thought it made it a little more inviting as a place to actually learn information. So as we go through, one of the first things you need is Autodesk Inventor. So you can click that link and it'll take you out to the Autodesk website where you can download for free a student copy of the 3D modeling software. So that would be the first step. Then it goes through and there's 6 lessons and an assessment. I'll go straight to the assessment part. It's a very simple assessment. Basically, the student is using all of the skills that I'm going to show you here in a few minutes. They're going to use all those skills to create an item of their choosing that's not loaded on the list here. They'll have to go through all the steps. And then they'll use either Weebly or some other digital medium to create screenshots of their work. So the assessment starts out right off the bat. And it's all linked in here, so it's very easy for them to all get to. So lesson 1 is the interface. This is a video that I pulled off of YouTube. This is not my video, and it just kind of works through. Basically, it's provided by Autodesk, and it just starts out with the interfaces.
In Autodesk Inventor, you use 4 base environments: Part with an IPT file extension, Assembly with an IAM file extension, Drawing with an IDW file extension.
So in this one, it goes through the interface, and the student can actually figure out what all is in the interface. It's a pretty simple little lesson. So lesson 2 would be creating project files. Again, it's got an embedded video with the project files video linked to it, so you can go out to it if you want. But back in the video itself,
let's take a look at how do we create.
So that was a video I created. And then getting back into here, what do I do? So after viewing this tutorial, you're going to create a new folder. So this is part of the deal with Inventor, is I teach you how to create a folder, and then they'll call it the toy training. They'll be working through it that way. So then basic sketching, they're going to start creating parts. Again, another embedded video, and then some tasks. So there's a couple of tasks to do. So submitting screenshots into the conference room for people to share how they're doing so far. And then there's an office hours component with Google Plus, so that students can conference with me live during office hours. So it goes through and it does the same thing a few different times. Again, we have the run this time. We have the creating solids, and then we have the model train parts. So at this point, they'll be able to create some of these parts, and then there's a video on how to create each one of these little components, and they work through those. And then I include a measurement sheet, and then they have to post any questions in the conference room. And once they create all the parts for the train, then I work with them on creating an assembly where all the parts come together in a file. So again, this is a video that
Hey guys, Mr. Wemp back again.
It's
Last time
for
we
a different project, but you can see the same theory applies. It's a real straightforward video on assembling components together.
Some basics for assembly.
So then they would be able to watch this and go through, again posting questions in the conference room. So once they've worked through all that, then they should be able to pop into the assessment that I showed you earlier. They'd be able to pull this up, and they'd be able to 3D model a simple item from home. So the way that this was working for students is then I actually used this particular lesson in my second level class for students that had bypassed the first level class. And one of the components that they had for college credit is they had to be able to do 3D modeling. The second level course of pre-engineering didn't deal a whole lot with 3D modeling, but it was a component. And so if a student joined up without having that class, then I would go ahead and run them through this unit just so that they get a taste of it, and then I would have a few things that I would do in the classroom to help them out. But this way, a self-starter would be able to go through. And you can see right here in the introduction that if you're working through this unit because you're in Principles of Engineering, you do not have experience in 3D modeling, please make sure to check in with Mr. Wemp after you complete each module. This collaboration will allow for correction of mistakes as you work through the process. So they have the first quarter to do it. So basically, it's a way for students to catch up on material that they have not had yet. And so there you have it. There's some artifacts that I felt encompassed my EdTech experience. All the classes kind of culminated to help me create some pretty solid lessons and some pretty solid processes. Any of those lessons, the content is not what's important. What's important is the process of how it was put together. Any of those lessons could be translated into any other course in an online environment. I invite you to go ahead and take a look at my portfolio, where there's a lot more artifacts linked in, and I'll link that at the bottom of the video. And thank you for viewing my presentation.